Okay, so make sure you have watched the video that I have posted about finding the volume when you're rotating a region around the x-axis. We're going to practice a few problems about that, and then I'm going to show you how that relates to rotating a region around the y-axis. So we have some problems here where I have labeled what f of x is. We don't know the function, and we're just going to call it f of x for now. And what we want to do is we want to rotate this region around the x-axis. So I want to rotate it this way. If you think about it, you've got some sort of like cone figure. The first thing that you should try to figure out is if there's a hole and if there's not. So I'm going to graph it over here just because I want to write on it, and when I do the y-axis I don't want it to confuse us. So we're rotating around the x-axis, and our radius always goes from where you're rotating to the outside. There's no hole here, so I know there's going to be a pi and something squared. Because there's no hole, it's only one thing squared. And we're rotating from around the x-axis, so it's the function minus 0. So in here is just f of x minus 0. And then we're going using the x-axis because these are x's, and so we're going from 0 to 4. And that's all you have to do on these type of problems. But I just want to talk about several of them with you to make sure that you understand the process. So again, I'm just going to kind of sketch it over here to the side. That way when we do the y-axis, we won't confuse ourselves with the picture and everything. So there's the figure. Again, I want to rotate this around the x-axis. I know it's going to be a pi and an integral and then something. So thinking about rotating this, well, actually there's a cylinder with this little part cut out of it, so that means that it's going to be something squared minus something squared. Going around the x-axis, so we know we're in x's. And we're going to go from here to here, 0 to 2. Alright, so start from where you're rotating and go to the outside of the function. That's at 3, so that would be 3 minus 0, or just 3 squared. And then start from where you're rotating and go to the inside of the function, so that would be the function minus 0, or just the function squared. Okay, another picture here. So it's this graph, and we're going around the x-axis, and this is the shaded part. Notice there is no hole, so it's just going to be something squared. We're using the x value, so we're going from 0 to 5. And from where you're rotating to the outside of the function, since it's just one thing, that's just f of x, so f of x squared. We'll do a few more together, and then I'll let you try some. You do not have to redraw these. Like I said, I'm just redrawing them so when we do the y-axis it won't be confusing. So it's that little region around the x-axis. And it does appear that there is a hole. So we'll have pi and then integral from here to here, 0 to 2, of something squared minus something squared. Alright, start from where you're rotating, going to the outside, so that's just the function minus 0, or just the function. Start from where you're rotating, going to the inside, so that's just 3, because that's where the line is, 3 minus 0, or just 3 squared. Alright, look at number 5. Alright, so pi integral. Alright, it does look like there's a hole because there's this part right here that's not touching the x-axis. So something squared minus something squared. So from where you're rotating to the outside, from where you're rotating to the inside. And so that would be that function, which is f of x, so f of x minus 0, and then the inside function, which would be g of x, so g of x. Okay, let's do one more, and then I'm going to let you practice some. So here's our figure again, going around the x-axis. It does look like there is a hole, and so something squared minus something squared. So we're going from 0 to the outside, which in this case is just 2, so this would be 2 squared. And then from where you're rotating to the inside, which that is the function, so f of x. Notice that sometimes the 3 is on the end, or the number's on the end, sometimes it's at the beginning, and it depends upon the volume and which part needs to come first as far as which part has a bigger volume. Now pause this video for a few minutes and go ahead and try 7 through 10. And after you're finished with 7 through 10, you can check those answers. Okay, here's the answers for 7 through 10. Be sure to check those. Let me know if you have any questions about how to work those out. And once you feel comfortable, we're going to go to the other column, which talks about rotating a figure on the y-axis. Now, we have not yet discussed what would happen whenever you rotate a figure about the y-axis, but it's very, very similar to what happens with area. The process is very similar to what happens with rotating on the x-axis. The difference is that you're going to have it in terms of dy, and that means that your limits will be y values and everything in the function will be y values. So let's look at number 1 and think about rotating this around the y-axis. So we're taking this part and we're coming around this way. So you still have this cylinder with this little bowl thing cut out. So the picture is very, very different from the x-axis, but process is the same. Again, I'll just draw it over here, that way we're not confused by the picture. You can draw it wherever you want if you need to draw it. I definitely like to write on it when I'm doing these problems. So you're still going to have a pi and an integral, and because we're going around the y-axis, there is a hole right here, so it would be something squared minus something squared. So it's going to be from where you're rotating to the outside, from where you're rotating to the inside. And so this is 4. 4 is on the outside, so that would just be 4 minus 0. And then the inside is the function, but we're going to put f of y here. We would have to solve that for x and get y's in the equation. And then instead of going from here to here, because we're going around, you need to go from here to here. So this is going to go from 0 to 3. Alright, let's do the next one. And this time we're going around the y-axis again. Notice that this figure does not have a hole. So it would be pi integral and then something squared. Alright, we're going to use those y values again. So we're going to come from here to here, which is 0 to 3. And from where you're rotating to the outside, that's just the function. So this would be f of y. I hope you realize this is very similar to the x-axis. I just wanted to make sure that I was able to share this with you. So the next one, we have a graph looking like this, going around the y-axis. It does not appear to have a hole, so I think it's just going to be one thing squared. We're going around y, so it should be 0 to 4. And when we rotate that, that is just the function, so just f of y, because we're coming from where you're rotating to the outside. Number 4, the picture looks very different because it's not on the x-axis, but I will tell you the process is exactly the same. There's still not a hole. The only thing that changes is that it would be from 3 to 4 instead of 0 to 4 like the last one. but still no whole, and we're still coming from 0 to the function, so that's just f of y squared. Alright, let's graph this one. Here's the graph going around the y-axis. There is a hole. So I know that there'll be something squared minus something squared using the y values, so 0 to 4. Alright, this one is the farthest outside, and that graph is g, but remember it's in terms of y because we're doing y values because we're going around the y-axis. This one is the one that's closest to the x-axis or farthest in, so that would be f of y and then dy. Alright, we'll do possibly one more. Actually, I think we'll just stop right there. I will let you try those and I will show you the answer. So pause the video now and work on those, and then I'll show you those answers. Okay, here's the answers on 6 through 10. Check and see if you're doing that correctly. I wanted to let you know that the reason that this one I marked it off is because when you rotate around the y-axis, there's two different pieces and they're coming two different ways. And so that is not a type of problem that you should know how to do. Now the work that you will be practicing will not have f of x and g of x necessarily. They'll actually be the functions, so you will need to insert like x squared or x plus 2 or whatever the functions are, and do need to go in the f of x places. And then the y places, you will solve for x and make sure that the functions are in, have y's in them when you put them into the equation on the problems that you're going to practice. You do not need to find the answers on the problems you're going to practice. You can just set them up just the way we did here.